Okay, so here is some help on Unit 11, Part A, Collision Theory, Castle Learning. So question 1 just says, why is the reaction faster with powder zinc than zinc strips? Because the surface area of powder zinc, we know that more surface area with a powder is going to have a better reaction, and the reason is that the more pieces it's broken into, the more collisions you can have. So remember, it's all about having more collisions, more effective collisions, harder collisions, anything more collisions. Okay. On to the next one. So always going to be a surface area question. Next question says, which sample of hydrochloric acid reacts the fastest? So here is, if I look at the choices, they're all like, okay, they're all 10 mils. I do see 2 different temperatures. So I did say that hotter is faster, and that makes sense, right? You picture boiling water as being fast. So this doesn't matter. I'm getting rid of the 210 temperatures. So I want the hotter temperature. So now all that's left is either a 1 molar or a 3 molar. So that's the only difference left. And we said the more concentrated, the faster, right? Like the 10% hydrogen peroxide elephant's toothpaste wasn't as fast as the 20%. So 3 molar is a stronger molarity, a stronger acid. So that's going to be our answer. We are going to pick the one, that got so messy, sorry, with the strongest molarity and the highest temperature. So you got to know high concentration, high temperature. All right, on to the next. Poop. There we go. Oops, I said poop. Okay, the effect of a catalyst on a chemical reaction is to provide a new reaction pathway. So that's always, they're gonna say provides a different reaction pathway. So remember I said like a shortcut, it's like, here, come here, take this easier pathway. It's faster and easier. Okay, so it offers a new reaction pathway, and they're always going to say it's going to lower that activation energy. So it's like, oh, now instead of having to get that high to get started, you only have to get this high with this catalyst. So you don't have to go as high. It's going to be easier for that reaction to get started. So that seems to always throw people off, that you actually lower the activation energy, because they're like, oh, lower energy, that's not it. But your lower activation energy, you don't have to go as high to get started. It's going to be an easier reaction to get going, so it will go faster. All right. You'll see that question asked over and over and over, and I just showed it because I kept finding it in all the recent Regencies over and over and over, so I wanted to show you how much they asked that question. Again, adding a catalyst, alternate reaction pathway, because it lowers the activation energy. See, I told you. All right. So what's that theory we learned about having the right energy and orientation to hit a home run or have a really good chemical collision theory? I didn't think they would ask it that way, but that actually is a 2018 question right there. So they could ask it that way. You never know, the things that the Regents does. Okay, this is also a 2018 question I was surprised at. So it says, which diagram, blah, 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 picture, which diagram represents the most likely orientation of X2 and Z2, where they would collide with the proper energy and orientation, producing a really good activated complex. So you got to really just look at all the stuff they gave you. Here's the stuff they gave you. Here's the activated complex. So if that's how they want the activated complex to be, I probably would like them to be lined up like this, so that it looks the most like the activated complex. So really weird way of asking you if you know the correct orientation. I was really surprised at that question, but again, that was 2018. So every year they surprise me what they ask. So I'm trying to expose you to all of it. 7, chemical reaction occurs when particles have collide with proper energy and proper orientation. You got to collide, you got to hit hard, and you got to hit the right orientation. So to hit a home run, you got to hit that ball hard, and you got to hit it square on. You don't want to be under it. You don't want to be over it. You want to have a nice hard collision. All right. Moving on. Sorry, I'm kind of slow. Next question. Nope. Okay. The addition of a catalyst, blah, 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 alternate pathway. Yeah, so it's going to decrease the activation energy. And they show a nice picture here. Like normally for this reaction to get going, you have to have like 180 kilojoules of energy. But in this particular, once you add the catalyst, you only have to get up to 140 now. So it's going to be easier and therefore faster. So you will see that over and over again.